Hi and welcome everybody to the second part of this video about the inequalities. Inequalities using the function exponential, e. The first part we saw some very simple exercise, and now we go into something a little more challenging, but not about the calculation, but about the reasoning, the thought, the way we have to analyze our functions. A little look to our fundamental points. As you already know from my other videos, when we do analyze an inequality, when we want to solve an inequality, we have to follow some steps, simplify, do some calculation, some maths. After we have to analyze our function to find out what the pieces are of our inequality. Analyzing our function will mean to cut it into pieces. After we analyze the domain of the single pieces and we obtain the domain of our function. We will study the sign of the single pieces, the elementary function, and we put everything together, obtain first the graph of the elementary function, the graph of the sign of the elementary function, and in the end the results we are looking for, a graph for the solution of our function. This said, let's go to our new exercise. This one, the fifth of the exercise we will look into in these two videos, is a little scale. As you see, we have e to a very big exponential, square root of x plus sinus x to 3. To this exponential we add 1, and we want to know when this function will be greater than 0. First step, of course, we do not need to simplify anything. It's already simplified. Let's analyze this function. What are the elementary function, the pieces that made it up? E to x to y, the exponential function, a square root sinus y to 3, operator sum here, and a constant. These two, as always happen, we do not take care about them. They do not create us problem, at least in this part of the exercise. Let's look at the domain. E to y is defined for every real y. Square root of x is defined only for non-negative number. X will be greater than or equal to 0. X can be any real number. The sinus here is defined for every real number, and so x to 3. In this case, the function domain will be the domain of the less good function. I mean the square root, which accepts only non-negative numbers. Our function will be defined only for x greater than or equal to 0. Only positive number and 0. Let's look at the sign, but before to do any difficult calculation, we can note one simple thing. We know from the elementary function e to y is greater than 0 for every real number. That means we do not have any idea of what the value will be of square root of x, sinus the x to 3, and so on. I mean, this exponential can have the power it likes. This value can be any real value. We do not bother about it, because e to this exponential will be always positive. This is a very important point, because to this function, which is positive, we add another positive number, it's 1. So e to epsilon plus 1 will be greater than 0 for every y belonging to the real number. I mean, our function will be strictly greater than 0 for every real number. Again, I do repeat to let you to understand very clear this situation. Here we have an exponential function, e to y. This y here is a function that can assume only real values, but for every real values, e to y will be always greater than 0. We add another quantities, 1, which is greater than 0. Of course, we obtain something that will be greater than 0. So we don't bore. We don't need to know what value x will assume. It will be always greater than 0. So this equation, which looks very scary, can be solved in a few seconds. Only remember this quality of the exponential function. Every number we choose, e to y, will be always positive. Let's move on to another exercise. This time we will have to do a little effort. We will have to make some math, some little calculation. E to sinus x minus 1 greater than 0. Analyze and domain of the function. They are both defined for every real number. Of course, the function which makes up our function is the function r, e to y, and sinus x. Now, we do not think about minus 1. As we know, we will look at it after. Let's study the sign. We know very well now that for every non-negative y, e to y will be greater than 1. So we have to look at the sign of sinus of x. If sinus of x will be greater than 0, we will obtain that e to y will be greater than 1. When the sinus of x will be greater than 0, we have to remember what we studied during our trigonometry course. The sinus will be greater than 0 when it will be between 0 and pi. Of course, we have to add 2k pi because sinus has a period of 2 pi. So the correct form to write down this solution is 0 plus 2 times k times pi minor than x less than pi plus 2k pi, where k, of course, is 0 plus minus 1 plus minus 2 plus minus 3. If x will be equal to k pi, sinus of x will be 0. So now we know everything we need to know to graph a solution, because we know when sinus will be greater than 0, and if sinus is greater than 0, so e to y will be greater than 1, and we will solve our inequality. Of course, sinus is a periodic function, so periodic will be our solution. Remember, k is a relative integer. Now our function will be greater than 0 for x, which will for 0 plus 2k pi less than x less than pi plus 2k pi. Our function will be null if x will be equal to k pi, and our function will be less than 0 if pi plus 2 k pi less than x less than 2 pi plus 2k pi. Thanks a lot, guys.